interpretation of that number can be a little bit misleading. So here's my buddy, Max, my little guy. When he was 2, he's 6 now. But this was the 2-year checkup. And the reason I bring up the 2-year checkup, this was the last one I was invited to come to. And you're about to find out why. The last thing you want is a statistician at a physical. The last thing you want, because the doctors, they just get frustrated with you really, really quickly. So anyway, there's my buddy. Took him to his 2-year checkup, 24-month checkup. Here are the results of his 2-year checkup. He's in the 80th percentile for weight, 90th for length, and my personal favorite, the 85th percentile for head girth. That was without hair. They shoved his hair down. I think he's in the 110th with his hair included. All right. So, we're sitting there and they're giving us these numbers. I'm like, I love them. I love them. And then what they said next, I want to come back to. Because they started asking me questions about this one. And I want to come back to that once we understand exactly what the percentile means. And I asked this because, well, if you were given these values, can you explain them? You're out in your yard, you're doing yard work in spring, you're trimming your bushes, and your neighbor comes over and says, hey, your son had his checkup, right? Yeah. Well, how'd it turn out? That was an 8th percentile for weight. What the hell does that mean? What would you tell them? What the hell does that mean?
Top 20%.
Explain. What does that mean? Rich?
Top 20% of kids in that age and...
So he's in the top 20% of age, of weight in that. We've got Rory saying yes, Valerie saying yes, good. Anybody else?
Isn't it like 80% of kids his age are that heavy?
Are that heavy? 80% of kids his age are that heavy? Love it. There's a percentage in here somewhere. I've heard 80% now used 2 ways. Thank you, John. Appreciate that. Anybody else? With experience or without experience? Rory, go.
He's 80% of what he should be?
He's 80% of what he should be, so he's actually malnourished a little bit, okay? No, I'm just... See this kid? No, I want to come back to that. That's actually what this discussion, how this discussion started. Thank you. And then Sarah, you're like, no, hang on, go ahead.
Well, it's on average. It's an average of how many kids, and he's at the 80th%.
He's at the 80th percent of the number of kids, which I think ties into what she was just saying, I believe. It's potato, saying it 2 different ways, above 80, below 20, good. Anything else?
Well, I never really paid much attention to it for
Rachel.
my kid because I never knew what the heck they were comparing it to. Like, how many kids are they comparing to?
Yeah.
Because I know that, for example, my child was never sampled for a percentile.
Damn it!
I don't want to discriminate on, but you know what I mean?
Rachel, to answer your question, I don't have your child's weight in here, but I went ahead and sampled 99 other white American 2-year-old males. And I threw Max in there too. So I had his weight from the appointment, threw it in that chart, and put 99 other randomly selected white American 2-year-olds in the... Can you find Max in that list? Where's Max? He's in there somewhere.
80%, 30.
30. No, I heard an answer no. 28. 30. 27. Love it. Other guesses? This is a pain in the butt to look at, yes?
Yeah, it is.
Rory?
No, was the test all like, was it racial? Like,
Well, I did this, I kind of forced race onto it a little bit, only because the chart they were using was for white American boys.
Okay, well.
So I'm comparing this to white American 2-year-olds.
Okay. But
I mean,
the doctors don't test, like, they're not like, you're in the average for whites.
Well, that's what the chart they actually pulled out had written on it.
Oh, okay.
It actually was Caucasian 2-year-old
Okay, so it
males.
is by that.
No, that's a good point though, because this came up in the other class too, it's a wonderful point. What if there are racial differences? Because statistics has discovered some racial differences, not necessarily in 2-year-old weights, but say like death from heart disease.
Yeah.
Apparently African American males die at a slightly higher rate, or maybe even much higher rate than Caucasian American males. So I'm not saying that's not worth looking at, I'm saying that that's not what we're comparing Max to.
Okay.
It's a very, very good point. Sharon, go.
Doesn't it mean he's bigger than 80%
Which-
of the 2-year-old?
I think that's what Sarah was getting at. Did you hear what Sarah just said? Doesn't it mean that he's bigger than 80% of 2-year-olds on average? Which I believe echoes what Sarah said, I think. Maybe in a slightly different way. Let's come back, if it's okay. Now, I noticed that most of you aren't giving me a definition of what percentile rank is. That's okay. You might have never either heard the term before, or if you've heard it, you might have just kind of flushed it away as, oh, it's a percentage, I hate those. Or maybe it's you just haven't had to deal with them yet. Nursing students. Nursing students in here, do I have any? You guys have to deal with this with the TEAS exam. You gotta, sorry, not to bring up that awful thing, but you have to deal with a certain percentile score on that, right? And it becomes a little bit cutthroat. You remember the movie Flatliners? There's an old movie from the 80s called Flatliners. One of the earliest scenes in that movie, the professor walks in. It's this cadavers class, anatomy class, where they're cutting open cadavers. And she says something along the lines of, on this exam, 1 will get an F, 2 will get a D, 6 will get a C, 2 will get a B, and 1 will get an A. She doesn't say that if you get a 90 or above, you get an A. She says 1 will get an A, which means the highest score will get an A. Well, that makes it cutthroat. Imagine if I treated you guys like that. By the way, the highest person in the class, you get an A, the rest of you can fight for C's. It's ridiculous. But that's kind of the same idea of this, believe it or not. This is less cutthroat, though. There's a reason to this. Rachel, to your question again, as far as the size, this is a sample drawn from a basically infinitely large population. We'll come back to that momentarily, too. Very good points. This is a pain to look at, right? Okay. There. That's the same data in a much, much easier to digest form. Broken down in essentially a dot plot. Essentially, it's a dot plot, 20 to 33 pounds. Why is this easier to look at?
Seahawk blue.
It's Seahawk blue. Yeah. Being from Philly, none of this makes any sense to me. Seahawk, like who played? What? The Union? Hasn't woke up on yet? So, why is this better?
It's organized.
It is organized, least to greatest. We've got frequency counts. Check it out. We don't even lose any exactness or precision in the values because it's a dot plot. There's no ranges. It's 20, 21, 22, 23. Please.
How much did he weigh? I'm curious.
Well, that's what I want you to tell me.
Oh.
How much did he weigh?
Well, it makes a lot less sense now, because if you're looking at out of 100 children sampled,
Here they are.
20 of them were Max's weight or above. Is
Boom.
what that means
Yeah.
to me.
Did
So-
you? Good!
Yeah.
So right away, you guys tell me, okay, so when you said this is less clear, it's more clear now.
I would think it was less clear than looking at the data before. Because,
Oh, really?
Yeah, because I would think that so that would mean that he weighs more than most kids, but looking at this, statistically, he weighs the exact same as most kids.
How are you using the word most?
Out of the 100.
Out of those.
Because 30, where
Mhm.
like I would think he would be at from that 80th percentile, there are the most children in that category.
Is that the 80th percentile?
I don't know.
This comes back, thank you, Shreddy. Let me just ask, I have a couple questions. First of all, describe the shape of that data.
Bell curve.
Bell curve? Anybody disturbed? It's a little bit skewed? It's a teeny bit skewed. But you can essentially call it a bell curve if you want. I would probably pull away from calling it a perfect bell curve only because of this guy. Because there's no corresponding one on this side balancing. There's no like 50-year-old, 2-year-old. Thank God for that. But it's a little unembellished to me. So as soon as something, and there's measures for skew. You guys are going to look at it in, I believe, in your exam. I think I told you to look at a skew. Maybe I didn't yet. If I didn't, I'll eventually have you do it. There are measures for skew. But when I look at that, I'm like, it's kind of like a leaning bell. And as soon as it talks about a leaning bell, I get wary of using the average. Because the average might be underrepresented on this. If we start talking about the averages, it's going to start heading south towards these little guys down here. It's going to be the opposite of the Facebook data, where it might head towards the upper values. So that's where percentiles shine. Percentiles don't go how much more does Max weigh than other kids. It just says, is he heavier than them? Doesn't matter how much heavier. Is he heavier than them or not? So let me ask you a question. Suppose Max was 25 pounds. 25 pounds, okay? If he were 25 pounds, how many kids in this sample weigh less than him? How many kids in this sample weigh less than him? If he were 25 pounds.
12, 13, 13.
13? Well, there's 4 there. 6,
Oh.
8, 9, 12. So 12% of the sample, which we can slap a margin of error on. Emily, thank you for that from earlier. Let's call it 12%. 12% of the sample is lighter than Max. So I don't think Max is there, because that's only 12%.
So 80% would have to be lighter than him.
Based on the definitions that I keep hearing from Richie and also from Sarah and also from Sherry, it sounds like 80th percentile means he's heavier than 80%. Go find him. Go find him. What is he? We had some votes on it. 27, 28, 30, 32. Is he 33?
I think he's like,
No.
like he's like
He's not 33, is he?
30,
Which percentile is this kid?
99.
99.
He's 99th, isn't he? He's bigger than everybody except himself. So he's 99th percentile, right? How about 32? There's 8 of them, plus the 33 kid.
91st.
That's 91st percentile, isn't it? Because 9, 9 are equal to 32 or higher, that means 91 or less. What's 31?
That's 80.
Max. So, Laura, your question, how much does Max weigh? He weighed 31 pounds at this appointment, because if you look at this random sample, there are 31, it was 11 plus the 9, that's 20. There's your 20% above, or at or above, I should say, as just as you said, Richie. At or above 20%, that means 80% is below. That is the most general form of a percentile that you can get. Here, I gotta skip ahead a little bit here. The reason he's in the 80th percentile is because he weighs more than 80% of those in his class, in this case, 2-year-old Caucasian American boys. That's it. That's it. That's the easiest way to think about a percentile. There are other ways to calculate it, but they're all arguably the same thing. I'll talk about that momentarily. That's what that however is about. I want to talk about that too. Richie?
Wouldn't it be weighs more than 79%? Because he's 80.
Hold that thought. Give me 2 minutes. I want to make sure this kind of washes over first, but I want to get back into this nitpicky however thing. The big idea is this one. What percentage of the data are you bigger than? That's your percentile rank. Okay? Now you can micromanage how you calculate that. And I do want to go back to the chart to look at that again, but this is the big idea about percentile rank. Questions, comments right now about this?
I never thought about percentile being like that.
Why would you have to? And the thing is, it's often misused. Anybody ever been to a doctor's appointment where their kid has said they're 103rd percentile? I had a couple parents a few years ago that said, they said my kid was on 103rd percentile. I'm like, so they're bigger than everybody their age, including themselves, plus 3% of the next age? I'm like, well, that's how they explained it to me, and I'm like, okay, so logically that makes sense-ish. Logically that makes sense, but here's why it doesn't make sense as soon as you think about it statistically. So, which I put there. Statistically, it makes no sense. So suppose here's Max's 2-year-olds. Okay, here's I'm going to call them bell-shaped, even though it was slightly skewed. And there's the average weight, and so forth and so on. So let's suppose this kid, who's 2, is in the 105th percentile. So where is he on this curve?
Way to the right.
Technically, he's off the curve, yes? Technically, he's off the curve. And he's so far off the curve that he's where?
The next curve.
On the next curve. Which makes me think that there's some other curve over here. That he's actually in the lowest part of that. What's the problem with that drawing?
Not Bell.
He's not classified in that other.
Yeah.
That's stupid.
What's that right there?
Age.
Yeah, it separates the
That
two.
separates the ages of, say, 2 to 3.
Yeah.
Is there anything wrong with drawing the curves like this?
Well, no, but you would have to classify him in that one.
Well, I think there might be something wrong with it, though, because wouldn't the curves look more like this? Aren't there going to be some very small 3-year-old kids that are smaller than the
Yeah.
biggest
Yeah.
2-year-old kids? You see what I'm getting at?
Yeah.
I mean, there have to be. I've seen them, just because I've watched my kid go through kindergarten. And he's a fairly large, I mean, he's starting to even out now. He's more like toward the 50th percentile now as he gets older, which is perfectly sensible when you look at the variation in the data. We'll look at that later, too. But this is what actually happens. What you do is you get these successive humps. Now, they begin to spread out as they get older. But at least in the beginning, when they're 2 and 3 and 4, the humps they're not exclusive. You have parts that get shared. So saying you're in the 103rd percentile because you're bigger than also 3% of the next age group, that's actually taking percent away from you, because that bottom 3% is actually this way on the previous curve. Not to mention that that doesn't make any sense. How can you exceed more of the data than it's actually there? Make sure you give 112% this weekend. How? Borrow somebody's leg? Richie, go.
Well, shouldn't you go by months? Because there's some kids that are November or whatever, and some, yeah.
This is a very, very interesting point, which we'll analyze again in 244. Next time you guys are at a professional sporting event, you don't have to buy one, but look at the program that you can get at those events, and look at the roster. Look at the roster of the players at the event, and look at their birthdays. There will be a disproportionate number of January, February, and March birthdays.
Oh,
Because when the kids are teeny tiny and they start playing Pee Wee League, whatever, football, baseball,
Right off the bat.
they're bigger
Yeah,
right off the bat.
yeah.
Maybe not better, but they're bigger.
Yeah.
So if you're born early in the year, you have an almost unfair advantage because you're going to get the best coach, because the coach is going to be like, this kid's awesome. No, he's 9 months older than the other kid, but they're only 4 years old. That's 25% advantage.
So I
Yeah.
was trying to hold their kids back too. Like
That's possible too. That's possible too. But you can't fight with a birthday. You can't fight that.
Yeah.
With the birthday, it's just genetic advantage.
Or
Or
not,
actually,
not
not
they always
genetic.
try to fight.
Age, just age advantage.
Just age advantage, right? And at an early age is a larger percentage. So Richie, yes, I agree with that statement. Rory, go.
When you throw out the lowest and the highest,
Recenter. Let's go back.
So you can have 105%, so you can have a negative percent too.
Well, mathematically, yes. It doesn't make any sense though.
Yeah.
So mathematically, for sure, you can have a negative percent.
But they don't throw out the highs and lows in percentile ranges.
And this goes back to what Rachel was asking about. Where do these numbers came from? These are extrapolated or actually interpolated, I guess, from the infinite data set that exists. They have, if you will, the usual minimum weight for a 2-year-old after measuring hundreds of thousands of kids over decades. And the same thing with the maximum weight. They've got ranges established, except for the extremes. We'll come back to that, if that's okay, Rory. Hold that question for maybe 5 minutes. It's a great question. Rachel, go.
I find that interesting too, because that could be just births in American hospitals, birth versus home births, midwives, you know.
We are definitely leaving some data out, of course.
Yeah.
These people are measured by healthcare professionals in healthcare facilities that then report the data, which means we're underreporting certain segments. You're absolutely correct. You're absolutely correct. The question I have, and I don't know the answer, is if we were to include those, A, would it change the values at all, and B, would it A, would it change the values at all? I had a B and now it's gone. Would it change the values at all? So in other words, are there enough of them and are they deviant enough to shift the overall trend? I don't know the answer to that, either of those questions.
Yeah.
Cool, thank you for that. Rory, let's hold that question. The problem, the reason I bring this up, and the reason I think this is interesting to you, goes back to Max's original question. Which was, so Daddy, what does it mean? And here's why I bring it up. 2 years, this is why I wasn't invited back after the second year. Given that, oh, Max is 31 pounds, that's 80th percentile. We're like, okay, cool, I'm just nodding along. My wife knows statistics as well as I do. Nodding along. And the healthcare practitioner goes, so what do you eat? What are you feeding? My wife goes, food. Look at her, for God's sake, look at his cheeks. You know, food. And then the practitioner did not find that humorous. What kind of food? And I go, that's broccoli, right, babe? Loves broccoli, cheese sticks. Cheese sticks. How does he have cheese sticks? Like, one a day before swimming, sometimes after swimming he gets hungry. Really? How does he have swimming? And I'm like, what are you getting at? What are you getting at? And the healthcare practitioner said, well, 80th percentile for weight is an automatic trigger. Any weight over the 50th percentile, which timeouts, hold that thought, Lauren. What would the 50th percentile be? You already know a word for it. Careful, careful.
Average.
What average?
The average.
Average.
Which average?
For a healthy weight.
It's a word you already know. No, forget this for a second. What is the 50th percentile? It's the divider between the lower and upper half of the data.
Midpoint.
Somebody just said midpoint, we call it the median. Your 50th percentile is your median. Remember how we used to do, we line them all up and find them, that's the median. 50th percentile is median. I'm sorry, pause, unpause. Anybody over median gets the obesity talk. As I'm opening my mouth to contest that, my wife goes, well, do you also then give the anorexic talk to anybody under 50?
Yes.
And the healthcare practitioner goes, well, yeah. I'm opening my mouth to contest that, and my wife goes, so basically, you're giving every parent a talk about how they're not feeding their kids right. Now, my wife was harsh, and I love you, babe, it was awesome. But what's lost in that very brutal attack is the fact that, go ahead.
His height, he's in the 90th.
That's the problem.
Yeah.
What's lost is, yes, he's in the 80th percentile for weight, but he's also in the 90th for height. If this was 80 and that was 10,
Yeah, they're
imagine that kid.
Yeah.
80th percentile weight, 10% length, 85th percent head girth. You think Charlie Brown about 2 feet tall. Maybe a little brown. Snow kid. Right, but when you look at one data point in lieu of the rest, thank you. One data point in lieu of the rest. That's what my wife was picking at. It was so awesome just watching her go to work. Like, what's up, babe? It's funny, she gets invited back, I don't. I thought I was like spurring her on or something. But here's the thing, me. Anybody ever have their BMI tested?
Yeah.
Anybody ever? I am this close to being overweight every time I get my BMI measured. I'm 24.7, I believe, on my BMI chart. I think 25 is that cutoff for overweight. Borderline overweight, every single time. There
Because
you go.
they don't count for your muscle mass.
They don't account for that or
Bone.
body fat percentage,
Yeah.
bone density, lean muscle mass, which essentially is body fat percentage. What's calculated in BMI?
Just your height and weight.
Height and weight, and that's it. Height and weight, and that's it. The only way I cannot be viewed as almost overweight is if I grew another half an inch. I'm 40, I'm shrinking at this point. So that's the problem with looking at one data point, like this one, without looking at the rest of them. Look at my BMI. While you're at it, look at my BSA, which is my body surface area. How much skin do I have? How much skin do I have? You can approximate that using certain calculation. While you're at it, throw my body fat percentage in. At 12% is my 175 pound weight at 12% body fat something to write home about? They're like, "She's overweight."
No.
Probably not. Rory, go.
I know our country has a high percentage of obese people, but is that calculated from the BMI? of
That is
obese
calculated
people?
from BMI.
It is calculated from BMI, and it's also calculated on what level you call obese.
And also according to nutrition, that's completely inaccurate.
It is.
History of.
If it's all based on BMI, I got an issue with it anyway. The other problem too is, so BMI, those of you that never used, anybody ever never heard of BMI before? You've all heard of that before. So it's basically you feed your height and your weight into a, let's calculate mine real quick, what the hell? See if it's changed. Let's see. BMI calculator, all right.
Was the pediatrician flustered?
With both me and Jen there, yeah. So feet, I'm 5 feet, 11 inches. I weigh 175 on my last, there we go. 24.4. Look at this, normal weight, 24.9. I am this close to being overweight. This close. So the question is, who the hell says 25 is overweight? You see what I'm saying? All these decisions be made about obesity. I'm not saying that Americans are or aren't more obese than they were 50 years ago. I'm not making that claim. My claim is, how are you classifying that? What defines obese? If it's defined as poorly as my son's 80th percentile was interpreted, I got issues with it. So who sets this range up? Normal. What is normal? Why is underweight less than 18.5? I remember sitting across the table with my brother-in-law, love you too, Drew, and he was looking at a climbing magazine talking about how they now check BMI for climbing competitions. Or they were back in 2009. What a stupid-ass idea. You ever seen rock climbers? They're whipcord, sinewy, muscular beasts. They're off the chart BMI-wise for their weight and their height. It's ridiculous to even talk about it. I mean, they're super tall and super lean. They can climb these things upside down. Gorgeous. They're also mostly underweight by BMI calculations because of that off the chart that way, as we're talking about. So you gotta question the measure. Always question the measure and find out how the measure is being calculated. As soon as I hear that most of the country is obese, I go, how are you measuring obese? Probably this, yes?
Which is very inaccurate.
Oh, there is obesity, 30 or greater.
Couldn't they measure it though by like if you're in that category and then you start having like health issues and they kind of
Cross-reference, another variable? Yes, but you see what you're doing right there? You're bringing another variable in. That makes me happy. We can correlate a BMI of 30 or greater with an advanced risk of heart disease. Then I'm like, hell, this is the equivalent of looking at Max's 80th and comparing it with his 90th and going, when we see 80th without the 90ths, or saying 90ths or lower, we see certain health problems. We told you guys about introverts versus extroverts and how they're followed after 30 years, the crybabies versus the non-crybabies. That's the kind of stuff I want to see. I don't want to see just a definition used in lieu of something else. I want to see it tied to something else, Rory, just like that. Sorry, no. But it's frustrating. 80th percentile, obese, or overweight, or whatever. I mean, now, I don't fault the practitioners for caring, obviously. They care, right? They care. But the fact that you're looking at one number and then looking at me and my wife as if we're feeding our kid wrong, it's like, dude, watch it. Yeah, Rachel.
Just out of curiosity, on the bottom of that webpage, is there info on how they calculate that, where their info comes from?
The formula has got a square root in it. I know that.
Yeah.
Hang on. BMI formula. If you had me in Math 105,
It's height, it's over
there it is.
Height in inches.
There it is.
Height in inches squared.
There you go. Sorry, I thought it was a square root. It's not a square. It's a square root. Take your weight in pounds times 703. Why? I don't know. Times your height squared.
Height in inches. Height in inches squared.
Height in inches squared. So there you go. Why? Why 703? Hell if I know. It's some constant, I'm sure, that cancels the height, the inches. And
Oh, it converts it to kilograms. It says right there. Something.
Oh,
It takes your weight. To
oh, it puts it in metric. Oh, raw. That's quite nice.
Yeah.
Sherry?
Well, just kind of on the arbitrary weight thing with what's BMI. When my youngest was born, he was 10'1".
10 pounds, 1 ounce.
Yeah.
You're saint.
So they were saying that, well, any over 10 pounds were concerned about diabetes. I was like, well, never mind that the last kid weighed 9 pounds 13. So they ran all kinds of tests on it.
An isolated event, which get you in all kinds of trouble if you don't see it. Sally Clark, I'll leave you with this one story to echo what Sherry just brought up. London, a lawyer, back in the 90s, I believe, lost a child. The cause was ruled to be cot death, which is called SIDS in this country. They call it cot death in England. Baby just dies during the night. Terrible. I can't even imagine. I mean, it's so much worry when your little one is that young. Put them on their back, wrap them up in the little friggin' Ewok suit, make sure they're. And then 2 years later, a second child died, cot death. And then she was tried for murder, and her husband were tried for murder because they said, well, the chance of a cot death in England is like 1 in 8,000. It's very rare. The chance of 2 cot deaths is 1 in 64 million. For those of you who are wondering how to do that mathematics, your second project will answer that for you. So anyway, 1 in 64 million, because they assumed that the deaths of the children in the beds at night was completely independent of the second child and the first child. So she was tried, put on trial, the statistician got on the stand, did that math. They said, that's beyond a reasonable doubt. You're going to jail, put her away for murder. Then the statistical community caught wind of it and like, time out. Time out. Whoa, whoa. Did you bother looking at records, death records over the past 10, 20 years? The judge was like, no, we had a statistician come up and do 1 over 8,000 squared, which again, that'll make sense in your second project, I promise. And the statisticians go, yeah, but you didn't look at death records. There were 7 other families in England that had 2 children die via SIDS within the past 20 years. So the chance of having 2 kids die from SIDS goes from 1 in 64 million to basically 1 in 8. Which is not unusual. 1 in 8. That's like having 3 kids in your family, all girls, which is not that. Anybody have a family where there's just, there we go. It's not very rare now, is it? Or all boys. Anybody have 3 children, family, all boys? No, we got the all girls, that's fine. But the point is, it's not rare. 1 in 64 million is ridiculous. That's like having a family with, make up a number here, 23 kids, all of whom are girls. Ridiculous, first of all, and secondly, very, very rare. So, Sherry, what happened there, same thing happened with you. They ignored the first data point and viewed the second one. Not realizing there's probably a tie between them. I was 9'5" when I was born. My sister was 10'3", I think. My mother's a saint, But the fact of the matter is, sometimes there's a tie that creates a pattern that cannot be viewed as independent. More on that in your second project too, about independence versus dependence. Billy's like, oh my god, the second project already. Let's take 5. You look glazed. That was a lot of case studies all at once in right there. Yes.